At the end of this video, students should be able to find one-sided limits, where limit x approaches a from the right fx equal to L, and the limit x approaches a from the left fx equal to m. Limits which consider values of x on only one side of a are called one-sided limit. One-sided limit can be divided into two. The first one is we call as right-hand limit. Right-hand limit is the limit x approaches a from the right for the function fx equal to L. Second, we call as left-hand limit, which is limit x approaches a from the left fx equal to m. Limit of the form limit x approaches a fx equal to L are called two-sided limits, since the values of x get closer to a from both the right and left side of a. Let's look at the one-sided limit based on the graph. The first one, left-hand limit. The limit of f as x approaches a from the left is m. Look at the graph, and we want to find the limit as x approaches a here from the left. So we can see that the graph is approaches to m. Then look at the right-hand limit. The limit of f as x approaches a from the right is L. Based on the graph, we want to find the limit x approaches a from the right. Then we can see that the graph is approached to L. Therefore, we can say that the limit x approaches a positive or from the right for the function fx is equal to L. Two-sided limit. The two-sided limit is we want to evaluate the limit x approaches a fx. We need to consider the limit x approaches a from the left and limit x approaches a from the right. Based on the graph, when x approach to a from the left, we can see that fx approach to L. And when x approach a from the right, fx also approach to L. Therefore, we can conclude that the limit x approaches a fx is equal to L. Remember, limit x approaches a fx exists if the right-hand limit is the same as left-hand limit. But the limit x approaches a fx does not exist if the two-hand limit does not equal. It means that the value of the right-hand limit is not the same as the value of left-hand limit. Based on the given graph, approximate the value of both one-sided limits as x approaches 3. So this is the values of x. The first one, limit x approaches 3 from the left. Look at the graph that less than 3. This one, the first graph. When x approaches 3 from the left, move your pen from the left, approach to 3, and you can see that at the same time, your fx is approaching 2. Then, when we want to find the limit x approaches 3 from the right, look at another graph. Try to approach 3 from the right, and you can see that at the same time, fx is approaching to 3. Example 11. Evaluate the following limits if exists. For part A, limit x approaches 4 from the right for the function square root x minus 4. So if we directly substitute x with 4 and we get 0. But for this question, we cannot do that because we want to evaluate the one-side limit, which is the limit x approaches 4 from the right. So we need to try to imagine another value that very close to 4. When x approaching 4 from the right means we can substitute any value of x that bigger than 4. Okay? When x approaching 4 from the right, for example, I can take x equal to 4.001. Very close to 4, but not equal to 4. So try to imagine that when I substitute 4.0001 into the function minus 4 and I get 0.0001, which is that value is very close to 0. Then square root of 0, we get also 0. Therefore, we can conclude that the limit x approaches 4 from the right for the square root of x minus 4 is approximately equal to 0. Evaluate the following limits for part B. Limit x approaches 4 from the left for the function square root x minus 4. If we can see that the function of f is the same as part A, but now we want to evaluate the limit x approaches 4 from the left. If we directly substitute the value of x, then we get square root of 4 minus 4, which is 0. Remember, we want to evaluate the limit x approaches 4 from the left when x become closer and closer to the 4, but it is from left. So, from the number line, the value of x that approach 4 from the left, it can be 3.9999, very close to 4. Okay, so if we substitute 3.9999 into the function f, okay, minus 4, and we get something negative here, 0.0001. And if we square root the negative value, it is impossible to get the answer. This is undefined, because square root cannot be negative inside the set. So what we can say about the limit x approaches 4 from the left for the square root x minus 4, we can see that the limit does not exist.